And so how do we use the periodic table to help us find the size of our atomic radius? Starting with adding energy levels, you can see as we go down, it increases. And that's because if we think back to when we were learning how to do our Bohr model, every time we go down a row, we're adding another energy level. So the first row only has 1, the second row has 2 energy levels, the third has 3, and so on. And so by the time you get to row 7, the atom has 1, 2, 3, 4, 5, 6, 7 energy levels. And you can see that because it has 7 energy levels, it's a lot bigger than what we started with 1. And so as we go down the periodic table, and we move on to elements that are in a higher row number, so are like up towards 7, the atomic radius gets bigger. So the atomic radius increases. Now, when we add on electrons, we are talking about adding on electrons in the same energy level. So that means they are all in the same row. So if we look at row 2, this is all row 2. Lithium has 1 electron in the second shell, because we have 2 on the inside, but it has 1 on the second shell. Beryllium has 2 on the second shell. Boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7. And this should look familiar because these are our valence electron numbers. And so as we go across and we're adding electrons, it gets smaller. So it decreases. So atomic radius gets smaller. When you go from left to right, and that's because we are adding on electrons. And when we add on electrons, it becomes more attracted to the center. So electrons are more attracted to the nucleus. And so that is why it gets smaller as you go across. So let's recap. When we're looking at the periodic table, atomic radius increases when you go down. And that's because we're adding on another energy level, another ring around the nucleus. So it gets bigger. When we go across from left to right, it decreases. And that's because we're adding on more electrons to our outer shell. And when we add on more electrons, it becomes more attracted to the nucleus.